What lurks in the darkest corners of our universe? Are we really alone in the cosmic immensity? These questions, as old as mankind itself, are now being answered by a giant eye turned towards the stars. The James Webb Telescope. Launched in December 2021, this revolutionary observatory offers an unprecedented view of the farthest reaches of space and time. From distant galaxies to mysterious exoplanets and the birth of the first stars, the James Webb pushes back the frontiers of our knowledge. Dear traveler, welcome. Today we're off on an extraordinary exploration of the most fascinating discoveries made by this hunter of cosmic mysteries. But before you set off on your next adventure, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a great trip! The universe is thought to have appeared around 13.8 billion years ago with the Big Bang, followed by the formation of the first stars and galaxies after a few 100 million years, a period known as the Cosmic Dawn. This phase represents an important research frontier for astronomers who seek to understand the formation and properties of the first galaxies. Despite intensive efforts with telescopes such as Subaru and Hubble, only a few galaxies dating back a few billion years have been discovered, and their precise distances remain uncertain. This difficulty is due to the lengthening wavelengths of light from ancient galaxies, which are now mainly in the infrared spectrum, making observation with today's telescopes more complex. For this reason, the James Webb Telescope is specifically designed for observations in this wavelength range. The Webb Telescope's unique capabilities can be compared to an astronomical time machine. By capturing the infrared light of these distant objects, it enables astronomers to see the universe as it was shortly after its formation. This gives scientists an excellent opportunity to study the composition, structure, and evolution of the first stars and galaxies, as well as the physical processes that led to the formation of the universe as we know it today. The James Webb Telescope has already made significant progress in its mission to explore the outer reaches of the universe. Among its notable discoveries, it has identified a set of galaxies that formed just a few 100 million years after the Big Bang. In the distant future, some 13.4 to 13.5 billion light-years from Earth, 3 galaxies had already been confirmed through precise observations, but it was not yet clear whether these discoveries ran counter to existing theories. Now, with the discovery of 2 new galaxies by the James Webb Space Telescope, 5 galaxies have been identified in the early universe, dating from around 300 to 400 million years after the Big Bang. In other words, we are observing these galaxies as they were only 320 million years ago, and even 290 million years after the Big Bang for the latest discovery, when the universe was only 2% of its current age. The discovery of these 5 galaxies was not predicted by the theoretical models available prior to the launch of the James Webb Telescope. Astronomers measure the distance to a galaxy using its redshift. Because of the expansion of the universe, distant objects appear to be moving away from us, and their light is stretched to longer, redder wavelengths, rather like the sound of a police siren that changes as it moves further away. To estimate this redshift, astronomers use images taken through different filters, but to obtain precise measurements, they need spectroscopy. This technique involves breaking down the object's light into its different colors or wavelengths, enabling the exact amount of redshift and therefore the object's distance to be determined. The most distant galaxy confirmed to date is Jade's GS Z14-0, discovered by the James Webb and showing a redshift of 13.2, which corresponds to a distance of around 13.5 billion light-years. Understanding the early development of galaxies is essential to understanding their later evolution. Just as in human beings, much of what happens later is influenced by the first generations of stars. These observations reveal a mechanism in the early universe that actively promotes star formation, challenging long-held theories of star and galaxy formation. Another possibility is that these 5 galaxies shine thanks to the activity of supermassive black holes. This would suggest the existence of such black holes in the early universe, raising questions about their birth and growth. We can't yet determine which hypothesis is correct with current observations. This will be a major topic for future studies with the James Webb Space Telescope. Furthermore, this discovery has shown that in a large part of the universe, stars are forming more actively than expected, shedding light on the epoch of the cosmic dawn. It is possible that even the earliest galaxies experienced intense star formation. In addition, the James Webb Telescope has detected a rapid increase in oxygen and nitrogen-rich galaxies, as well as numerous supermassive black holes in the early universe. Thanks to its exceptional capabilities, the telescope has discovered unexpected objects and phenomena in the distant universe. We are now very close to understanding the time of formation of the first galaxies, marking a true revolution in astronomy. This discovery is particularly important, as it offers a glimpse of the young universe at a time when the first galactic structures were beginning to form. Studying these primitive galaxies allows astronomers to better understand the processes of galaxy formation and evolution. This includes studying the physical and chemical conditions of the primordial universe, as well as the evolution of the first stars and supermassive black holes. By identifying and analyzing these early galaxies, the Webb telescope will help scientists understand how modern galaxies, including our own Milky Way, have evolved over time. The James Webb Space Telescope recently studied Earendel, the universe's most distant star to date. Recognized as one of the most fascinating celestial objects, Earendel has revealed some of its secrets thanks to James Webb, offering a valuable glimpse into the early universe. Indeed, Earendel was born when the universe was only 7% of its current age, around 900 million years after the Big Bang. Having long ago gone supernova, its light took 12.9 billion years to reach the Earth, and with the explosion of the universe, it is now 28 billion light-years from our planet. Because of this immense distance, even the powerful Webb telescope would not normally be able to see this star. However, a massive galaxy cluster lies in the line of sight between Earendel and Earth. The galaxy cluster between us and Earendel is so massive that it distorts the fabric of space-time, creating a gravitational lensing effect. This magnifying effect allows astronomers to look through the cluster as if using a magnifying glass. While other features of the galaxy appear several times due to the gravitational lensing effect, Earendel manifests itself as a single bright spot, even in high-resolution infrared images from the Webb telescope. On this basis, astronomers have concluded that the object is magnified by a factor of at least 4,000, indicating that it is extremely small. It is the most distant star ever detected, observed as it was 1 billion years after the Big Bang. Moreover, thanks to its observations, the Webb telescope was able to determine that Earendel was a spectral Class B star. This indicates that its surface was twice as hot as that of the Sun, and that its luminosity was 1 million times greater than that of our star. In addition to these properties, the data collected suggest another peculiarity. Earendel is not alone. Scientists have identified signs of a companion star orbiting the star. Unlike Earendel, this twin star would have a lower temperature, resulting in a reddish hue. This potential discovery raises new questions about the formation and evolution of such binary stellar systems in the distant universe. At present, the researchers are continuing to analyze the observational data to learn more about the composition and distance of Earendel and its host galaxy. They hope that this could represent a step towards detecting the very first generations of stars formed solely of the primordial elements created during the Big Bang, namely hydrogen and helium. In the future, scientists hope that the Webb telescope will be able to detect traces of population 3 stars. These stars, among the very first to form in the universe, are thought to have masses far greater than the most massive stars known today. The detection of such stars would offer interesting insights into the early stages of stellar evolution and the formation of heavy elements in the early universe. In a new discovery, the James Webb Space Telescope identified evidence of a collision between 2 giant asteroids in a nearby star system. This massive collision generated 100,000 times more dust than the impact that caused the extinction of the dinosaurs. The impact occurred recently in Beta Pictoris, a star system located some 63 light-years from us, in the constellation of Painter. Beta Pictoris is a young system just 20 million years old compared with our own solar system, which is 4.5 billion years old. Discovered in 1983 by IRIS, NASA's infrared astronomical satellite, Beta Pictoris is thought to have formed from the shock wave of a nearby supernova. Currently, Beta Pictoris is home to at least 2 large gas planets, but no rocky planets like Earth have been observed. However, giant collisions like the one detected by James Webb could contribute to the formation of rocky planets. The circumstellar debris disk of Beta Pictoris, composed of gas and dust around the star, is a highly turbulent place, ideal for studying the early stages of planetary system formation. Scientists believe that this recent collision between large asteroids shows how rocky planets and other bodies are still forming. Webb's new data suggests that we have observed the aftermath of a rare and cataclysmic event between large asteroids, offering valuable insight into the history of our own solar system and planet formation. These discoveries will enable astronomers to better understand how stellar systems form and how often habitable systems like our own appear. The James Webb Space Telescope has also observed black holes, achieving a record detection at 570 million years after the Big Bang. This means that the most distant active black hole discovered to date by a telescope dates from well after the Big Bang. Despite its relatively young age, this black hole is already 9 million times more massive than our Sun. By comparison, the black hole at the center of our own Milky Way galaxy has a mass equivalent to only 4 million suns. The discovery made by the James Webb Telescope has rekindled the debate as to how the first black holes were able to grow so rapidly to such impressive sizes and masses, equivalent to millions or even billions of times that of the Sun. More to the point, how did they develop so rapidly? The results could also shed light on a larger enigma. Which came first, the galaxy or the supermassive black hole? Observed supermassive black holes feed greedily on the surrounding material, generating immense tidal forces in a disk of matter called an accretion disk, causing this disk to light up. This situation feeds objects called quasars, which are found at the heart of active galaxies. Quasars are among the brightest objects in the cosmos, some being so bright that they outshine the combined light of all the stars in nearby galaxies. Supermassive black holes also remain mysterious, especially when observed less than 1 billion years after the Big Bang, in the 13.8 billion year history of the universe. Indeed, the process by which supermassive black holes grow, involving the continuous merging of black holes, is expected to take several billion years. So how could these giants exist only 1 billion years or so after the Big Bang? Using the James Webb Telescope to observe the faint light emitted by stars in the host galaxies of 6 ancient quasars, a team of researchers has, for the first time, gathered evidence to suggest that supermassive black holes in the early universe did indeed grow from heavy seeds. These observations imply that in the primordial universe, supermassive black holes may have acquired their mass before that of their host galaxies, and that the initial seeds of black holes may have been more massive than they are today. Discovered in the 1960s, quasars were initially perceived as single star-like points of light, hence their name, an acronym for quasi-stellar object. Researchers soon realized that this intense luminosity actually comes from vast quantities of matter building up around supermassive black holes at the center of galaxies. However, these quasars are surrounded by stars that are much less luminous and more difficult to observe. The light from these stars is eclipsed by the much brighter light from the quasar around which they orbit. Separating the light of quasars from that of the surrounding stars therefore represents a considerable challenge, comparable to discerning the light of fireflies amidst that of a lighthouse lamp a kilometer away. Thanks to the James Webb Space Telescope's ability to observe farther back in time than any previous telescope, as well as its high sensitivity and resolution, this challenge has been mitigated. The team of researchers was thus able to observe light from 6 quasars in ancient galaxies, traveling towards Earth for around 13 billion years. The quasars shine so brightly that they outshine their host galaxy by several orders of magnitude. The images obtained by previous telescopes were not sharp enough to clearly distinguish the host galaxy and its stars. Thanks to the much sharper images provided by James Webb, it is now possible to reveal the light emitted by these stars by carefully modeling the quasar images. The data collected by James Webb included measurements of the light emitted by the 6 quasars at different wavelengths. These data were integrated into a computer model to determine how much of this light comes from a compact point source, the accretion disk around the black hole, and how much from a more diffuse source, the stars scattered throughout the galaxy. By separating the luminous contributions, the research team was able to estimate the mass of both elements in these galaxies. They found that supermassive black holes possessed masses equivalent to around 10% of the total mass of the stars surrounding them. While this may seem like a significant imbalance in favor of stars, it's interesting to note that in modern galaxies, central supermassive black holes account for just 0.1% of the total mass of stars in their surrounding galaxies. This raises the question of which grows first, the black hole or the surrounding galaxy. Observations suggest that black holes in the primordial universe appear to grow faster than their host galaxies. This discovery provides clues that the initial seeds of black holes may have been more massive back then. After the formation of the universe, seed black holes consumed matter and rapidly increased in size. One of the great challenges is to understand how these black monsters were able to grow so rapidly. There must be a mechanism that allows a black hole to gain mass ahead of its host galaxy in those first few billion years. Many astronomers propose that these black holes formed not from the collapse of massive stars followed by a gradual buildup of mass, but rather through the direct gravitational collapse of vast clouds of gas present in the early universe. According to this hypothesis, these massive gas clouds would have given rise directly to supermassive black holes without passing through the intermediate stages of star formation and star death. New observations by the Webb telescope could provide evidence in support of this hypothesis. By studying the properties of black holes and their environment, astronomers hope to gain a better understanding of how black holes form and grow in the early universe. The Webb telescope's infrared vision is useful not only for finding distant galaxies, but also for studying objects closer to our Milky Way that are hidden by dust clouds. Dust blocks visible light, but allows infrared radiation to pass through. This is why the Webb telescope has proved to be an indispensable tool for studying star nurseries, those regions of active star formation where new stars and planets are forming as we speak. Thanks to its infrared capabilities, the Webb telescope can penetrate these dust clouds and reveal details invisible to optical telescopes. By observing regions such as the Perseus Nebula, it has been able to identify very low-mass objects that often escape detection. Thanks to the power of the James Webb Telescope, astronomers have discovered the smallest floating brown dwarf known to date, with a mass only 3 to 4 times that of Jupiter. Brown dwarfs, sometimes called failed stars, form as a result of the gravitational collapse of a gas cloud, but their mass is insufficient to trigger complete hydrogen fusion reactions, although reactions involving deuterium and lithium can occur at depth. The lightest brown dwarfs are at the limit of the giant planets in terms of mass, making their classification complex. Astronomers have long sought to determine the smallest mass that can form like a star through gravitational collapse. For this study, they observed the IC 348 cluster. It's an open cluster about 1,000 light-years from Earth, located in the constellation Perseus and around 5 million years old. This means that the brown dwarfs present are still hot and emit active infrared radiation. Using James Webb, the researchers identified 3 objects ranging in mass from 3 to 8 times that of Jupiter, with surface temperatures ranging from 830 to 1500 degrees Celsius, or 1526 to 2732 degrees Fahrenheit. Simulations have shown that the mass of the smallest of these objects is only 3 to 4 times that of Jupiter. 2 of the brown dwarfs discovered also show a spectral signature of an unidentified hydrocarbon similar to that detected by the Cassini mission in the atmospheres of Saturn and Titan, as well as in the interstellar medium. Current models of brown dwarf atmospheres do not predict the presence of such compounds, making their formation difficult to explain. Indeed, it is much more complex for a small cloud of gas to collapse under its own gravity to form a brown dwarf, especially when the mass of these objects is comparable to that of planets. The question remains, are these bodies discovered by James Webb really brown dwarfs, and not giant planets ejected from their systems? While the possibility cannot be totally ruled out, researchers consider it unlikely for two reasons. Firstly, high-mass straight planets are rare compared to lower-mass planets. Secondly, the majority of stars are low-mass, and it is rare to find giant planets on them. It is therefore unlikely that the majority of IC 348's low-mass stars would have produced such large planets. What's more, the age of the cluster, just 5 million years, leaves little time for the formation and ejection of giant planets. In the future, astronomers plan to continue their observations. Theories suggest that stray planets are often found on the periphery of star clusters. Therefore, extending the search area could reveal more in the IC 348 cluster. In addition to its ability to study star nurseries, the Webb telescope also offers new insights into the formation of planetary systems. By observing protoplanetary disks around young stars, it can provide valuable clues as to how planets form and evolve. This includes the detection of rotating grains of dust and gas that will eventually agglomerate to form planets. Protoplanetary disks are of great interest to scientists as they are essential to the life cycle of stars and the formation of planetary systems. It is within these disks that planets are born. It all begins in molecular clouds, immense clouds of gas and dust. Under the effect of a disturbance, certain regions of the cloud lose their stability and collapse, forming protostars. These protostars, only a few tens to hundreds of thousands of years old, represent the equivalent of a few hours in a human lifetime. During this phase, the protostar is still surrounded by a dense cocoon of collapsing gas and dust, which fuels its growth. Over hundreds of thousands of years, the temperature and pressure inside the protostar increase until nuclear fusion reactions begin at its core, transforming the embryo into a star. At the same time, a protoplanetary disk forms from the gas and dust orbiting the young star. Observations show that these disks can reach a diameter of several hundred to 1,000 astronomical units and a mass of 0.001 to 0.3 solar masses. The structure of protoplanetary disks is not uniform. Their thickness varies with distance from the central star, giving them a bow tie shape. Density and temperature also fluctuate with distance, distinguishing the inner disk closer to the star from the outer disk. A protoplanetary disk can last several million years, during which time planets are formed. This process is at the origin of our own solar system. Around 4.6 billion years ago, a molecular cloud collapsed, giving rise to the Sun and a protoplanetary disk. Matter gradually agglomerated to form the Earth and the other planets of the solar system. Astrophysicists study disks to understand the exact conditions of planet formation and why some regions produce rocky planets like Earth, while others produce gas giants like Jupiter. The concept of the protoplanetary disk as the cradle of planets dates back to the 18th century, but it wasn't until the end of the 20th century that scientists began to understand its structure. The Hubble telescope was the first to spatially resolve the disks around stars in a nebula more than 1,000 light-years from Earth in 1992. The launch of the ISO telescope in 1995, followed by Spitzer in 2003, and the development of ALMA in 2011 have accelerated research into protoplanetary disks. Over the past decade, telescopes have become powerful enough to observe the closest disks to us, at least 300 light-years away. The James Webb Telescope, operating in the infrared with 100 times the sensitivity of its predecessors, marks the beginning of a new golden age for the observation of protoplanetary disks. Particularly powerful is its ability to observe hotter gas from 100 to 500 degrees Celsius in regions close to the star, where Earth-like planets are expected to form. James Webb is equipped with the MIRI instrument, comprising an imager and a medium-resolution integral field spectrometer. This instrument analyzes the molecules in the disks that modify the light emitted by the star, producing an emission spectrum in which each molecule has its own characteristic signature. The spectrometer allows us to see more detail and access the molecular content of the gas. For example, in the case of GW LUP, a young low-mass star around 500 light-years away, James Webb detected carbon dioxide, water, hydrogen cyanide, acetylene, and hydroxyl, as well as a carbon dioxide isotope 13C, labeled carbon dioxide for the first time in a protoplanetary disk. Another surprising example is J160532, a star 10 times less massive than the Sun, located around 500 light-years away in the Scorpio-Centaurus star group. By pointing the MIRI spectrometer at the disk surrounding this star, the astronomers discovered a spectrum rich in hydrocarbons with large quantities of acetylene, as well as benzene and diacetylene, molecules previously unknown in disks. Conversely, water and carbon dioxide, commonly detected in other disks, appear in small quantities. These observations open up new perspectives for understanding the chemical and physical conditions of protoplanetary disks, and by extension, the processes of planet formation. The James Webb Space Telescope is exploring a fascinating protoplanetary disk called D203-506, located in the Orion Nebula, some 1,350 light-years from Earth. This disk, unlike others, is a proplyid, i.e. a protoplanetary disk irradiated by the powerful ultraviolet radiation of massive nearby stars, notably those in the Trapezium cluster. These stars are enormous, some 30 times more massive and 200,000 times brighter than our Sun, creating extreme conditions for nearby objects. The regions irradiated by these massive stars are at the heart of a James Webb Telescope program. By observing the Orion Nebula, scientists have been able to see D203-506 in a whole new light. Here it's not the disk itself that the telescope is observing, but the gas that escapes under the effect of ultraviolet radiation. This phenomenon, known as photoevaporation, causes some of the gas in the disk to be torn off and escape rapidly, creating a gas wind. Analyses show that the D203-506 disk, which has a mass 10 times that of Jupiter, loses between 10 to the 8th power and 10 to the 6th power solar masses per year. At this rate, it would lose almost all its gas in less than 1 million years, making the formation of a gas giant planet like Jupiter unlikely. This discovery shows that massive stars can significantly influence planet formation in the disks they irradiate. The gas wind observed by James Webb also provides information on the chemical reactions taking place in D2O3-506. The material of the wind differs from that of the disk in density and temperature, but contains the same atoms. By examining infrared light spectra, the researchers identified the presence of hydroxyl, a molecule indicative of the presence of water. This discovery reveals a two-step reaction. When water is destroyed by ultraviolet radiation, it produces a highly excited hydroxyl molecule, ready to break apart too. The process produces a characteristic spectrum, detected in the wind, of D2O3-506. This observation is a first for James Webb, which has been able to quantify the amount of water destroyed. The equivalent of a terrestrial ocean is destroyed in this disk every month. Observations by the James Webb Telescope revealed a particular hydroxyl spectrum in the near-infrared, indicating an excited state that scientists had not yet identified. Other researchers performed calculations to determine the quantum state of hydroxyl when it forms in the gas phase, something the astrophysicists couldn't do on their own. These calculations showed that the characteristic spectrum observed resulted from a reaction between oxygen and molecular dihydrogen, marking the first stage in the formation of a water molecule. This reaction proved to be more significant than the photodissociation phenomenon. In other words, although the equivalent of a terrestrial ocean is destroyed every month in the D2O3-506 protoplanetary disk, an equivalent quantity of water is also reformed. This discovery is important for understanding how planets form in these disks, and could also shed light on the origin of water on Earth. In particular, it helps explain the abundance of deuterium, a stable isotope of hydrogen, in terrestrial oceans. A major discovery made by the Webb telescope concerns the detection for the first time of a methyl cation in the protoplanetary disk surrounding a young star. This simple molecule has a unique property. It reacts relatively little with hydrogen, the most abundant element in the universe, but interacts easily with other molecules, irritating the formation of more complex carbonaceous molecules. Carbon chemistry is of particular interest to astronomers, as all known forms of life are based on this element. The interesting role of methyl in interstellar carbon chemistry had been predicted in the 1970s, but it was only thanks to the unique capabilities of the Webb telescope that it was finally detected in a region of space where potentially habitable planets could form. This compound plays an essential role in interstellar chemistry, particularly in the formation of complex organic molecules. Methyl cation is a reactive molecule that participates in chemical reactions leading to the formation of larger, more complex organic molecules, essential to prebiotic chemistry. The presence of methyl cation in the protoplanetary disk indicates that complex chemical processes are already underway in these environments, long before planets were formed. This discovery offers valuable clues as to the initial conditions necessary for the formation of organic molecules that could eventually lead to the appearance of life. By observing these protoplanetary disks, the Webb telescope was also able to analyze the distribution and composition of ice and dust particles. These observations show that ices composed mainly of water, carbon dioxide, methane, and ammonia are present in abundance in protoplanetary disks. Ice plays an interesting role in providing surfaces on which chemical reactions can take place more efficiently. The data collected by the Webb telescope are also helping us to better understand the dynamics of protoplanetary disks. By studying the movements of gas and dust, astronomers can model the processes of planet formation and determine how materials aggregate to form larger and larger bodies. This information is essential to explain the diversity of planetary systems observed in our galaxy. In addition, the Webb telescope has revealed details of the temperature and chemical composition of protoplanetary disks. These observations show that temperature varies with distance from the central star, influencing the distribution of solid and volatile materials. Areas closer to the star are warmer, leading to the sublimation of ices and the formation of gas, while regions further away remain cool, allowing ices to persist. Methylcation, benzene, the water cycle. In just 2 years of data collection, the James Webb Space Telescope has revealed numerous discoveries about protoplanetary disks and planet formation. But the telescope goes even further into the past, allowing us to probe deeper regions and observe unprecedented stages. Thanks to James Webb spectroscopy, for example, we can remotely measure the size of ice grains in molecular clouds. Although these grains only measure a micron, their size is interesting. Grain growth influences many aspects of the molecular cloud, including planet formation. The aim of this research is to determine the initial conditions in order to better understand the evolution to the next stages. The James Webb Telescope also charmed space enthusiasts with a number of impressive portraits of various nebulae, from the famous pillars of creation to the supernova remnant Cassiopeia A. Not only are these images of exceptional artistic beauty, they are also extremely instructive. Thanks to its advanced technical capabilities, the Webb telescope was able to identify structures in each observation that had previously escaped astronomers' attention. These new observations have enabled us to better understand how many of the sky's pearls were formed and what processes are currently taking place inside these nebulae. For example, the pillars of creation, located in the Eagle Nebula, have revealed details of the formation and ejection of new stars within these gas and dust structures. Similarly, by observing Cassiopeia A, astronomers were able to study the debris and shock waves resulting from the supernova explosion, offering valuable clues to the final stages in the life of massive stars and the dynamics of supernova remnants. By combining these observations with theoretical models and simulations, astronomers can now reconstruct the history and evolution of these celestial objects with unprecedented precision. Each image captured by the Webb telescope not only marvels at its beauty, but also represents another step towards understanding the origins and evolution of the cosmic structures that populate our universe. The history of the universe's stars and planetary systems is being reconstructed brick by brick, thanks to James Webb and his instruments. And this is just the beginning. Another extremely important field of activity for the Webb telescope is the study of exoplanets. Its instruments enable astronomers to analyze their atmospheres with a precision unmatched by other telescopes. So far, the Space Observatory has lived up to expectations, making many interesting discoveries. One of these is the detection of rock showers on the exoplanet WASP-107b. This inflated planet was discovered in 2017. It is a gas giant also classified as a hot Neptune, exoplanets comparable in size to Neptune, orbiting an orange dwarf about 210 light-years from Earth, in the constellation Virgo. Recent images from the James Webb Telescope may have helped researchers understand why planets like WASP-107b appear bloated. Based on its radius, mass, age, and assumed internal temperature, researchers thought that WASP-107b had a very small rocky core surrounded by a huge amount of hydrogen and helium. However, they had difficulty understanding how such a small core could absorb so much gas without fully expanding to the mass of Jupiter. WASP-107b is almost the size of Jupiter, but only about a tenth as dense. To give a point of comparison, this exoplanet has a mass around 3 times that of Earth, while Jupiter is over 300 times more massive. According to NASA, WASP-107b is one of the least dense planets known. What's even more surprising is that it's less hot and less massive than other bloated exoplanets, such as the Jupiter-like gas giant WASP-193b discovered last year and also renowned for its extremely low density. Thanks to new data from the James Webb Telescope combined with older data from the Hubble Space Telescope, scientists are beginning to get some answers. The telescope detected only a tiny fraction of the methane expected in WASP-107b's atmosphere, suggesting that the planet's interior is much hotter than expected. This supports an earlier theory by astronomers that tidal heating is responsible for both WASP-107b's high internal temperature and inflated size. James Webb's data indicate that planets like WASP-107b are unlikely to have an atypical formation with a very small core and an enormous gaseous envelope. Instead, they could be more similar to Neptune, but with a predominantly rocky composition and less gas, where the increase in internal temperature is sufficient to explain their current appearance. In addition, the Webb telescope was able to detect water vapor, sulfur, and most interestingly, silicate particles that form clouds in WASP-107b's atmosphere. On Earth, clouds are made up of water droplets and water ice crystals, but on WASP-107b, whose atmosphere is heated to very high temperatures, silicates play this role. Their vapors rise, condense, and form sand clouds, sometimes producing stone rain. Then the whole cycle repeats itself. Understanding WASP-107b's atmosphere could also provide crucial information about dozens of other low-density, puffy planets and the reasons for their expansion, potentially helping to solve what NASA describes as a long-standing mystery in exoplanet science. Rocky clouds are just one of the many discoveries made by the Webb telescope when studying the atmospheres of exoplanets. In addition to these clouds, the telescope has managed to detect methane in several of them. Methane, a key organic compound, was previously rarely found on bodies outside our solar system. Although James Webb mainly detects methane in the atmospheres of hot, probably uninhabitable exoplanets, it has also identified at least one other potential candidate for harboring life, the details of which will be discussed below. Sometimes the absence of an element can be an important discovery. The Webb telescope is currently studying the famous TRAPPIST-1 system, a star much smaller and cooler than our Sun, located around 40 light-years from Earth, which has captivated the interest of scientists and space enthusiasts since the discovery of its 7 Earth-sized exoplanets in 2017. These planets, tightly clustered around their star, including 3 in the habitable zone, have fueled hopes of discovering potentially habitable environments beyond our solar system. The observation of this system used a technique called transmission spectroscopy, carried out with a James Webb's NIRISS instrument, to gain interesting insights into the properties of TRAPPIST-1b, the first telluric exoplanet in the TRAPPIST-1 planetary system. By analyzing the light from the central star after it passes through the exoplanet's atmosphere during a transit, astronomers can identify the unique fingerprints left by the molecules and atoms present in this atmosphere. The study revealed that stellar activity and stellar contamination have a major impact on our understanding of the nature of exoplanets. Stellar contamination refers to characteristics of the star itself, such as dark spots and bright areas called faculae, which can influence measurements of exoplanet atmospheres. The team found strong evidence that stellar contamination is essential in shaping the transmission spectra of TRAPPIST-1 and probably the other planets in this system. The activity of the central star can create ghost signals that can mislead observers into thinking they have detected a particular molecule in the exoplanet's atmosphere. This result shows that it is essential to take stellar contamination into account when planning future observations of all exoplanetary systems. This is particularly important for systems like TRAPPIST-1, which orbits a red dwarf, a star that is often very active, with frequent spots and flares. In addition to contamination by stellar spots and faculae, scientists observed a stellar flare, an unpredictable event where the star becomes brighter for a period of time. This flare affected the measurement of the amount of light blocked by the planet. These signs of stellar activity are difficult to model, but it is necessary to take them into account to interpret the data correctly. The 7 planets in TRAPPIST-1 are all interesting candidates in the search for Earth-sized worlds with atmospheres. However, TRAPPIST-1b, being the closest to its star, is in more difficult conditions. It receives 4 times as much radiation as the Earth, and its surface temperature is between 120 and 220 degrees Celsius, or 248 degrees Fahrenheit and 428 degrees Fahrenheit. Despite these conditions, TRAPPIST-1b is the easiest to detect and study thanks to its transit, which creates a strong signal. This makes it a crucial but complex target for observation. To take account of the impact of stellar contamination, the researchers used 2 methods to study TRAPPIST-1b's atmosphere. In the first, they removed stellar contamination before analyzing the data. In the second, they simultaneously modeled the stellar contamination and the planetary atmosphere. The results of both approaches showed that the TRAPPIST-1b spectra could be explained solely by stellar contamination, with no evidence of a significant atmosphere. Observations from the James Webb Telescope explored different atmospheric models for TRAPPIST-1b. Scientists have ruled out the presence of a cloudless hydrogen-rich atmosphere. However, they cannot totally rule out finer atmospheres, such as those composed of pure water, carbon dioxide or methane, or an atmosphere similar to that of Saturn's moon Titan. These findings, obtained from the first observations of the TRAPPIST-1b spectrum, are consistent with previous observations by the James Webb. They will provide valuable information for future observing programs by the James Webb and other telescopes, enhancing our understanding of exoplanetary atmospheres and their potential habitability. Among the exoplanets studied by James Webb, K2-18b is perhaps the most fascinating. This exoplanet orbits a red dwarf located 120 light-years from Earth in the constellation Leo, and is 8.6 times more massive than our planet. It lies in its star's habitable zone, which means it could have conditions conducive to life. Characterizing the atmosphere of exoplanets like K2-18b is a major challenge. These planets are literally dwarfed by the brightness of their much larger host stars. To overcome this problem, scientists have analyzed the light spectrum of K2-18b's star as it passes through the planet's atmosphere. K2-18b is a transiting exoplanet, which means that a decrease in brightness can be observed as it passes in front of its star. This is how K2-18b was discovered. During transits, a small fraction of the star's light passes through the exoplanet's atmosphere before reaching the telescopes. This light carries traces of the gases present in the atmosphere, which astronomers can analyze to determine its composition. The James Webb Telescope has detected specific molecules in K2-18b's atmosphere, notably methane and carbon dioxide. These gases are often associated with biological processes or conditions conducive to life. These recent observations confirm and reinforce earlier studies that had already identified interesting features of this exoplanet. Thanks to the accumulation of these data, scientists now classify K2-18b as a Hycean exoplanet. A Hycean exoplanet is one whose atmosphere is dominated by hydrogen and which has large quantities of water, often in the form of oceans covering its surface. This combination is of particular interest to researchers, as it could offer favorable conditions for the emergence and maintenance of life. Hydrogen is the most abundant element in the universe and plays a key role in many chemical processes, while water is essential for life as we know it. One of the most fascinating discoveries on K2-18b is the possible presence of dimethyl sulfide. This compound is a sulfur-containing organic molecule which on Earth plays an important role in certain natural processes. It is found mainly in the oceans where it is produced by phytoplankton. When these microorganisms decompose, they release dimethyl sulfide into the atmosphere, where it can contribute to cloud formation and influence the climate. On Earth, dimethyl sulfide production is mainly due to biological processes. If this molecule is found on an exoplanet like K2-18b, it could indicate similar processes, and perhaps even the presence of life forms analogous to terrestrial phytoplankton. However, it's important to note that the presence of dimethyl sulfide is not direct evidence of life. Other non-biological processes could also produce this molecule. However, NASA remains cautious. Although the signs of dimethyl sulfide are promising, further evidence is essential before we can definitively conclude that this molecule is present on K2-18b. Research continues to confirm these results and better understand the conditions on this fascinating planet. Even if K2-18b is in its star's habitable zone, this does not guarantee that it can support life. Its large size suggests that it could have a thick layer of ice under high pressure, similar to Neptune. However, unlike Neptune, K2-18b could have a thinner, hydrogen-rich atmosphere, as well as an oceanic surface. Exoplanets the size of K2-18b, located between those of Earth and Neptune, are unique and have no equivalent in our solar system. These sub-Neptunes, planets with masses smaller than Neptune, are still poorly understood. Nevertheless, recent discoveries suggest that they could offer interesting environments in which to search for signs of life. Researchers plan to use the Webb Telescope's MIRI spectrograph to further investigate these discoveries and obtain more information about K2-18b's environmental conditions. The astronomers' ultimate goal is to discover signs of life on a habitable exoplanet, which would radically change our understanding of our place in the universe. The Webb telescope is not only a powerful tool for exploring exoplanets and distant stars, but is also being used to study our own solar system with impressive results. It has produced detailed infrared portraits of the 4 giant planets in our solar system: Jupiter, Saturn, Uranus, and Neptune. These images revealed fascinating processes taking place in their atmospheres, such as storms and winds, as well as the complex structure of their rings. These observations offer an exceptional view of the dynamic characteristics of these giant planets. Thanks to the James Webb Space Telescope, a team of scientists has discovered never-before-seen features in Jupiter's upper atmosphere. These discoveries are located above the Great Red Spot, a zone of high atmospheric pressure producing a massive anticyclonic storm observed by astronomers since 1831. Prior to these recent observations, scientists believed that this region was devoid of complex atmospheric structures or activities. However, Webb has revealed that this area is scientifically fascinating, offering a better understanding of the inner workings of Jupiter and its immense atmosphere. Observing Jupiter in detail is a challenge, even with giant telescopes like Webb and Hubble. The glow of Jupiter's upper atmosphere is weak compared to that of the polar regions, making it difficult for visible light telescopes like Hubble and some ground-based telescopes to observe specific structures. However, thanks to Webb's sensitivity to infrared light, the telescope can observe the upper atmosphere without being hampered by the brightness of the polar regions. What's more, Webb's advanced design and size enable it to collect data in exceptional detail. Jupiter's upper atmosphere acts as a boundary between the planet's immense magnetic field and its inner atmosphere, considerably influencing its structure. For example, this region, aided by volcanic material ejected by the moon Io, produces brilliant aurora borealis and aurora australis. Near the planet's equator, however, atmospheric structure is determined mainly by incident sunlight. Given that Jupiter receives only 4% of the sunlight received by the Earth, scientists have predicted that this region would be less complex than the more northerly and southerly zones of the upper atmosphere. This hypothesis had yet to be verified, however, due to the lack of observations available for the equatorial upper atmosphere. The James Webb Telescope made it possible for the first time to observe these equatorial regions, notably above the Great Red Spot, thanks to the full field unit of its near-infrared spectrograph. The scientists' main objective was to determine whether this area was as uninteresting as assumed. However, Webb's data revealed that the entire region above the Great Red Spot is rich in complex structures and activity, including dark arcs and bright spots. Much of the light emitted by this region is reflected sunlight, but some of the structures and activities appear to be influenced by a mechanism other than sunlight. One hypothesis is that gravitational waves, generated in the depths of the turbulent atmosphere around the Great Red Spot, rise to altitude and modify the structure and emissions of the upper atmosphere. These waves, similar to those that crash onto a beach and create ripples in the sand, can be observed on Earth, although they are much weaker than those detected on Jupiter. The team plans to continue observations of these atmospheric wave patterns to understand how they move through Jupiter's upper atmosphere. This research will lead to a better understanding of the amount of energy present in this region and the evolution of the structures discovered by Webb over time. The Webb telescope also observed the moons of these giant planets, making some exciting discoveries. For example, it captured a massive geyser emanating from the underground ocean of Enceladus, a moon of Saturn. This geyser is an indication of geological activity and the presence of a liquid ocean beneath Enceladus's surface. Thanks to the James Webb Space Telescope, researchers have detected a plume of water vapor rising from Enceladus, reaching a length of over 9,600 kilometers, long enough to stretch from Ireland to Japan. Not only is this the first time such a water ejection has been observed over such a large distance, but Webb is also offering scientists an unprecedented, direct insight into how this emission supplies water to the entire Saturn system and its rings. Enceladus, a small moon of Saturn, measuring just 505 kilometers in diameter, is home to an ocean around 4% the size of Earth's oceans. This moon is a major target in the search for extraterrestrial life. Between its icy crust and rocky core lies an immense reservoir of salt water. Volcanic geysers shoot jets of ice, water vapor, and organic chemicals through cracks in the surface, known as tiger stripes. Until now, scientists had mapped these jets up to hundreds of kilometers from the surface. However, the sensitivity of the James Webb Telescope has revealed fascinating new information. Not only does the plume of water vapor reach unprecedented lengths, it also escapes at an impressive speed of 300 liters per second. Webb's observations show how these plumes feed a donut-shaped region of water, called a torus, which coincides with Saturn's E-ring. Astronomers have determined that around 30% of this water remains in the torus, while the remaining 70% disperses to hydrate the rest of the Saturnian system. In the future, the Webb telescope will be essential for studying Enceladus, informing future missions that will further explore this underground ocean, the thickness of the ice crust, and much more. For Europa, one of Jupiter's moons, Webb recorded carbon dioxide emissions. This could indicate the presence of carbon compounds in the ocean beneath Europa's surface, making this moon even more promising in the search for conditions conducive to life. Previous research had revealed the presence of a liquid saltwater ocean beneath Europa's icy crust, with a rocky bottom. However, paleontologists had not confirmed whether this ocean contained the chemical elements essential for life, notably carbon. The new analysis indicates that the carbon dioxide probably came from Europa's underground ocean and not from external sources such as meteorites. What's more, this carbon dioxide was deposited on a geologically recent timescale. This discovery has important implications for the potential habitability of Europa's ocean. Webb found that carbon dioxide is most abundant in the Terra Regio region, a geologically young and frequently renewed area known as the chaos terrain. This suggests a dynamic interaction between the subsurface ocean and the icy surface, with material from the ocean reaching the surface. The carbon dioxide appears to originate from the ocean itself, indicating an exchange of material between the subsurface ocean and the icy surface. Given that carbon dioxide is not stable at the surface of Europa, it was probably brought in recently on a geological timescale, enhanced by its concentration in a region of young terrain. Carbon is essential to life as we know it on Earth, forming the basis of organic molecules. The presence of carbon dioxide on Europa's surface suggests that this moon possesses one of the fundamental building blocks of life. Understanding the chemistry of Europa's ocean will help us determine whether this environment is hostile or favorable to life. The telescope also explored smaller objects in the solar system, notably the Centaurs. These celestial bodies, whose orbits lie between those of Jupiter and Neptune, have characteristics intermediate between asteroids and comets. Their study is essential to deepen our understanding of the formation of the primordial solar system, its composition, and the interactions between icy and rocky materials, shedding light on the origins and evolution of planets. These objects are made up of ice, dust, and rock, and can sometimes emit tails of gas and dust, making them fascinating subjects of study. One of these centaurs, named 39P Oumuamua, currently lies between Jupiter and Saturn, but some 60 years ago, it was much closer to the Sun, with an orbit inside that of Jupiter. Thanks to the James Webb Space Telescope and its spectrograph, which captures the near-infrared spectral signatures of celestial objects, 39P Oumuamua has been shown to have the lowest CO2 production rate ever recorded among centaurs and comets. Although the presence of carbon monoxide has been observed in 2 known centaurs, this recent discovery could represent a turning point in scientists' understanding of the formation, evolution, and composition not only of centaurs, but also of the early solar system. The study of centaurs is of great importance, as these objects are relatively well preserved in space and can offer valuable information on the chemical composition and physical processes of the early solar system. What's more, it highlights the James Webb Telescope's remarkable ability to detect the subtle nuances of low production rates in a relatively small celestial object located at an extraordinary distance from the Sun. In another discovery, Webb observed Chariklo, another centaur. Researchers used James Webb to observe the rings around Chariklo and were able to determine the size and structure of the rings surrounding this centaur. The researchers were particularly interested in how Chariklo's rings absorbed light from a background star as it passed behind it. This method, called occultation, is the same one used to discover Chariklo's rings. The observation of this event was made possible by the James Webb Space Telescope, which is capable of seeing stars much fainter than any other telescope. To make these new observations, the researchers made weekly forecasts of Chariklo's orbit and adjusted the telescope's position accordingly. This enabled them to identify 3 absorption bands of crystalline water ice. Although previous studies have suggested the presence of water ice in the Chariklo system, this is the first time such ice has been clearly detected. The presence of this ice indicates that micro-collisions are constantly exposing new surface material or triggering crystallization. In addition, the Webb telescope has made some unexpected discoveries. While calibrating its instruments, it managed to spot one of the smallest main belt asteroids known to astronomers. An unknown asteroid, measuring between 100 and 200 meters in length, about the size of Rome's Colosseum, has been detected by an international team of European astronomers using the James Webb Space Telescope. This project, using calibration data from the MIRI instrument, led to the chance discovery of this asteroid, which follows a very low inclination orbit and was in the inner region of the main asteroid belt during Webb's observations. This object is probably the smallest observed to date by Webb, and could be an example of an asteroid less than 1 kilometer long in the main belt between Mars and Jupiter. This fortuitous discovery demonstrates the telescope's sensitivity and ability to detect small objects in our solar system. Current models predict the presence of very small asteroids, but these have been less studied in detail than their larger counterparts due to observational difficulties. Webb's future dedicated observations will enable astronomers to study asteroids smaller than a kilometer. These data will refine our models of the formation of the solar system and our understanding of the planets, their moons, and the small celestial bodies that surround them. But it's not just cosmic objects that are subject to the sometimes puzzling temperament of the universe. In the early 70s, 2 space probes were launched, with the mission of making an initial reconnaissance of the planets of the outer solar system. In 1972, Pioneer 10 was the very first spacecraft to break free of the asteroid belt and fly past the planet Jupiter before reaching the liberation velocity required to leave the solar system, followed by Pioneer 11. The second probe took the opposite direction the following year, heading for Saturn after a close study of the Jupiter red spot. Unexpectedly, as the probes moved away from the Sun, an invisible force seemed to hold them back in their respective launches. The appropriate model, taking into account all the effects that could influence the speed of this type of craft in interstellar space, turned out to be wrong. As early as the 1980s, astrophysicists noticed that their speeds were steadily decreasing, despite their opposing trajectories. Although the probes had fulfilled their mission, their observation was continued over time, using the Doppler effect. For a long time, this phenomenon was downplayed as inherent to the probes themselves. Fuel leaks could have affected the probe's orbits. Or has the impact of radiant heat from the plutonium used, or of light on the solar sails, been underestimated? For some scientists, Newton's theories and Einstein's relativity are being called into question. This suggests that gravity could imperceptibly gain strength over enormous distances. But if so, why don't the planets themselves seem to be affected? In any case, the behavior of the Pioneer 10 and 11 probes continues to intrigue scientists. Delayed by 500,000 kilometers, or 310,000 miles in recent years, these 2 spacecraft have helped detect this anomaly, which, if not elucidated, could well upset the foundations of current physics. But before we enter our hibernation chambers and drift off into a deep sleep, let's take a closer look at one of Saturn's moons. Behold Titan, the only known cosmic object to exhibit a stable liquid surface mass. This feature, though extraordinary, is not the only one this satellite possesses. Even more disconcerting, near its north pole, in Titan's second largest sea, called Ligeia Mare, a luminous object seems to be playing hide-and-seek. Sometimes visible, sometimes nowhere to be seen, unlike its direct vicinity, this zone was explored as early as 2004 by NASA's Cassini probe. But it was in July 2013 that it was first spotted in images from the same probe, before disappearing again a few days later. The area, estimated at around 260 square kilometers, or 160 square miles, finally reappeared in images dating from August 2014. To everyone's surprise, its appearance was different from that observed 2 years earlier. Is it an object floating on the surface of the sea, which for some unknown reason remains static? Or is it simply a change in the landscape, suggesting the presence of dynamic geological mechanisms in Titan's atmosphere? Researchers have put forward several hypotheses about the nature of this strange island. It could be caused by waves linked to an atmospheric phenomenon, or it could be composed of gas bubbles emanating from the depths of this liquid expanse. The appearance could also be explained by the formation of methane ice, or even an increased concentration of suspended particles, such as silt floating between two levels of water. But for some scientists, these extraordinary changes on the Moon's surface are akin to the seasonal changes on Earth. Indeed, they have noticed that this mysterious island has always revealed itself at the beginning of summer in the northern hemisphere. It could, therefore, be linked to seasonal events, but over a longer period than our 4 seasons. As you can see, it's not only nature on Earth that has some surprises in store for us. This discovery, like a waking dream, brings us back to our collective phantasm, finding another habitable planet. Our sidereal journey now takes us to a strangely dark area of space. I invite you to step out of your chamber and let yourself be absorbed by this strange universe, virtually devoid of any visible matter. Faced with this enveloping, even deafening blackness, the surprise is total. Here you are in the middle of nothing, or almost nothing. But don't panic. Don't let this frightening environment overwhelm you. We're not sinking into an endless cosmic hole. Although space seems to be dotted all over with objects of varying luminosity, there are a few vast places where, strangely enough, emptiness dominates. We're currently right in the middle of one of them. It's the local hole, also known as the Keenan-Barger-Cowie Void, or KBC Void. This structure, or local subdensity, is no more and no less than a vast expanse, where matter has a density around 20% lower than the average of the observable universe. Studied in 2013 by 3 astronomers, the local hole closely resembles a sphere, around 2 billion light-years in diameter. And I'm going to surprise you. This cosmic void isn't as empty as it looks. I could even say that your cosmic address depends on it. In fact, it contains most of the Laniakea supercluster, including the local group, and consequently, the Milky Way. Our Sun is only a few hundred million light-years from the center of the local hole. Here's another piece of information that's sure to baffle you. Cosmic voids like this one exist in dozens of other, less exceptional dimensions. The only cosmic void larger than the local hole is nearly 3 billion light-years across. Thus, when observed on a very large scale, the universe resembles a cheese of holes, with zones rich in matter and others largely empty. Our galaxy and its wider neighborhood are therefore evolving in an immense empty bubble. According to the cosmological principle, the distribution of matter throughout the universe is fairly homogeneous, even over vast observed areas. While this can be confirmed on scales of around 250 million light-years, when we look at even larger regions, these cosmic holes appear. But what's even more interesting is that these voids could explain the discrepancy in Hubble constant measurements. Indeed, depending on the observational methods used, the expansion velocity of the universe presents contradictory values, known as the Hubble tension. The velocities of thousands of galaxies just located and counted were found to be 10% higher than those predicted by the Lambda cold dark matter model. Makes you wonder whether the standard Lambda cosmology model is really reliable, doesn't it? Could it be that unknown forces or manifestations are influencing our universe? This could explain why the model's predictions turned out to be wrong after these observations. The KBC vacuum is therefore a density anomaly, which in addition to challenging our current understanding of the dynamics of our universe, could provide the beginnings of an explanation for some major inconsistencies. Scientists at the University of St. Andrews recently put forward a hypothesis. The velocity fluxes of galaxies, i.e., the speed at which they move as a group across the universe, would naturally be higher in and near this cosmic void, rather than in constant acceleration. They suggest that galaxies located within, or relatively close to this void, would exhibit higher velocities due to differences in matter density and consequently discordant gravitational forces. In short, local variations in the expansion rate of the universe would be related to Newton's laws of gravity, which are supposed to apply uniformly throughout the universe. Thus, according to their theory of modified Newtonian dynamics, MOND, regions similar to this void would experience a weaker gravitational force, resulting in greater velocity. If this explanation proves relevant, in addition to challenging the foundations of gravity theory, it could mark the beginning of a new age in cosmological research. Your hibernation chamber, programmed to bring you gently back to a state of wakefulness, has just opened. Your eyes are immediately drawn outwards by countless luminous galactic filaments. Here we are, close to the largest superstructure in the universe known to date. You're looking at the Great Wall of Hercules' Crown Borealis, also known as the Great Wall of Hercules' Corona Borealis. This gigantic group of galaxies lies around 10 million light-years from our Sun, in the constellation of Hercules and Corona Borealis, as its name suggests. Its discovery, which dates back only to November 2013, can be explained in part by its remoteness. Scientists spotted it by mapping gamma-ray bursts, the dazzling explosions of the most powerful stars in the cosmos, far away and massive. But they had to be patient. Indeed, these explosions, which release more energy in less than 1/10 of a second than our Sun will produce in its entire existence, are extremely rare. In an ordinary galaxy, explosions of this type occur only exceptionally, at the rate of one every few million years. The stars that cause these cataclysms are very massive, requiring large quantities of matter for their formation. If these explosions can be used to pinpoint a galaxy or a large body of matter, they need to be the subject of lengthy study, involving the recording of colossal quantities of data. This is what astronomers set out to do, mapping these luminous phenomena from 1997 to 2012. To do this, they used the Fermi and Swift robotic satellites. The latter were designed to detect gamma-ray bursts by measuring their redshifts. The study of the data collected paid off. The map drawn up over 15 years of observation revealed 14 gamma-ray bursts with redshifts. What's more, these similar explosions were very close together. For scientists, there can be no doubt. This far-flung region of space is home to a very large group of galaxies and large quantities of matter bound together by gravity. According to their estimates, this structure, home to billions of galaxies, seems to measure 10 by 7.2 billion light-years. However, while it covers just over 10% of the diameter of the observable universe, it is only 900 million light-years thick. Until now, the largest observable structure in the universe was represented by the group of large quasars, measuring 4 billion light-years. To give you a better idea of these unusual dimensions, remember, our galaxy, the Milky Way, measures just 100,000 light-years in diameter and is only 2.5 million light-years away from its nearest neighbor, the Andromeda Galaxy. But how does this discovery fit in with the list of space anomalies? To cut a long story short, the Great Wall of Hercules' Corona Borealis doesn't fit in with the principle of cosmology, Albert Einstein's famous theory mentioned earlier. According to this principle, the entire universe is isotropic. Cosmology therefore stipulates that the universe is the same in all directions, spatially homogeneous, and similar at every point on a scale of several hundred million light-years. Thus, scientists who assume that matter has been evenly distributed since the creation of the universe predicted that no structure could be larger than 1.2 billion light-years. However, the Great Wall of Hercules' Corona Borealis is 8 times larger than this supposed limit, calling this cosmological principle into question. What's more, this imposing structure contradicts theories on the evolution of our universe. This glittering wall you can admire is some 10 billion light-years away from our Earth. This means that terrestrial observers have seen this structure as it existed 10 billion years ago. The famous Big Bang at the origin of our universe occurred 13.8 billion years ago. This difference is far too short. How could such a gigantic structure have formed in just 3.8 billion years? The existence of such a structure remains a mystery to astrophysicists. With their current understanding, they are unable to explain how it could have formed in such a short space of time. The Great Wall of Hercules' Corona Borealis could well compromise the veracity of the Big Bang theory. As their discoveries continue, astrophysicists are constantly adding to their list of enigmas to be solved. One of them is to explain the presence of rings around objects that shouldn't have them. As a reminder, only Saturn, Jupiter, Uranus, and Neptune, the giant planets, were equipped with these attributes in our solar system until this unexpected discovery. Introducing Chariklo, an asteroid discovered in 1997 that orbits more than 2 billion kilometers, or 1.2 billion miles beyond Saturn's orbit, deep in our solar system. While it is the largest member of the Centaur asteroid class, with a diameter of 302 kilometers, or 188 miles, it has been favored by many observers since 2013 for its astonishing peculiarity. This asteroid, around 50 times smaller than the Earth, has 2 rings. See how dense and narrow they are. Estimated at just 5 kilometers or 3 miles wide, they orbit at an estimated distance of 400 kilometers or 250 miles from the primary object. It is the smallest celestial body encircled by rings discovered to date. But it's not the only one. In 2017, a second such discovery was announced, this time concerning a small planet in the Kuiper Belt. Look at this piece of rock showing off its rugby ball appearance. It's Haumea, a dwarf planet averaging 6.5 billion kilometers, or 4 billion miles from our Sun. While trying to determine the size of this object, detected in 2004, astronomers discovered its particularly dense equatorial dust ring. No fewer than 12 telescopes pointed their lenses in Haumea's direction as it passed in front of a star, the ultimate condition for determining its dimensions. But to the great surprise of the researchers, a rapid extinction preceded the passage of this dwarf planet in front of the luminous star. They were able to establish that this dwarf planet, with a diameter approaching 2,000 kilometers, or 1,300 miles, is surrounded by a fairly narrow ring, around 70 kilometers, or 44 miles, but particularly dense, which orbits it at a distance of around 1,000 kilometers, or 620 miles. No explanation has yet been found for the origin of this ring. Is it an ephemeral phenomenon, or is it long-lasting? What is certain is that this anomaly could indicate that rings surrounding dwarf planets may not be as rare as scientists previously thought. In fact, an even more sensational discovery was made in the following years. This time, a ring was detected near an even more distant trans-Neptunian object. Meet Quaoar, a dwarf planet whose ring is not only unpredictable but also curiously located, hence its late discovery. In fact, Quaoar was discovered in 2002, while its ring was only recently detected and revealed to the public in February 2023. Quaoar was discovered by a team of American astronomers during Caltech's large-scale sky survey. As they surveyed the Kuiper Belt for the brightest objects, their attention was caught by a dark object of apparent magnitude 18.6. It was moving slowly in relation to its background, a cloud of distant stars. Scientists call this phenomenon occultation. Its diameter, quickly estimated using data from the Hubble Space Telescope, is around 1,110 kilometers, or 690 miles, giving it the status of a dwarf planet. It is also one of the largest objects in the Kuiper Belt. In addition to its size, this dwarf planet has a satellite. It's a moon, about 170 kilometers or 105 miles, called Weywot. But what's even more incredible is that this small planet, which orbits our Sun at a distance equivalent to 43 times that separating the Earth from the Sun, is surrounded by an extraordinarily distant ring. With a radius of 4,100 kilometers or 2,600 miles, it lies well beyond the Roche limit, defying previous models for the formation of such a structure. No other ring has ever been detected so far from its planet. This one is more than 7 times its radius, marking the boundary of the Roche limit. According to this model, a ring could not exist beyond 2 to 3 times the radius of the central body. This discovery is an anomaly for scientists, running counter to the above-mentioned model, whose origin lies with astronomer Édouard Roche. The rings are not supposed to exist in such a remote perimeter. The particles of matter present in this zone should have agglomerated with each other, since they are not subject to the tidal effects produced by the main body, which are greater than the gravitational cohesion forces taking place between them. And yet, despite being outside the Roche boundary, these numerous pieces of debris don't seem to be undergoing this long agglomeration process at all. So how does such a ring manage to endure over time? Here's one more mystery for astrophysicists. The icy temperature of the ring's debris could provide the beginnings of an explanation. Some scientists believe that the ice particles undergo so-called elastic collisions, preventing them from sticking together. So what you have before you is an exceptional, unusual, even inexplicable ring, at least for the time being. Admittedly, it doesn't have the splendor or grandeur of Saturn's rings. Nevertheless, its position in relation to Quaoar makes it unique, especially as it hides the secret of its very existence for the time being. But how about a little rest? After observing these anomalies, each more disconcerting than the last, a good night's sleep will enable us to tackle the next stage of our exploration with slightly clearer skies. The next time we wake up, a new surprise awaits you. Look at this exceptional star. This is Tabby's star, one of the most mysterious and exciting stars in the Milky Way, just 1,470 light-years from our Sun. Tabby's star, which cohabits in the constellation Cygnus alongside numerous other luminous objects, stands out from its companions in a singular way. Although first detected in 1890, Tabby's star has been the subject of particularly close study in recent years. The reason for this is its unusual light fluctuations. While the Hubble Space Telescope recorded variations in the brightness of over 100,000 stars in the Cygnus and Lyra constellations, data collected between 2009 and 2013 led astronomers to take a closer look at this star. For scientists searching for exoplanets, the brightness fluctuations recorded are unmistakable. There is probably a large mass or many small masses in close formation in its vicinity. This is why there is so much interest in this star, potentially accompanied by an exoplanet. Observations show that the star displays an atypical light curve for a number of reasons. It shows both periods of deep decline and long-term changes. On several occasions, its brightness has declined to as much as 22% of normal. What's more, a study of the archives revealed that this seems to have been happening repeatedly over a number of years. Now, if a planet the size of Jupiter were to occult this star, not only would it lose no more than 1% of its brightness, but more importantly, these changes in brightness would be cyclical. Except that, in this case, the fluctuations are totally random. Scientists then speculated that it could be an occultation linked to a random phenomenon occurring between Tabby's star and the observation zone. But this hypothesis doesn't hold water, especially as periods of significant brightening have also been recorded. I'm not going to hide the fact that the idea of an extraterrestrial megastructure has occurred to a few followers of this dogma. A Dyson sphere set up by an alien civilization would then be able to appropriate some of this light to meet its energy needs. But this idea was dismissed as preposterous by most. In fact, as you can see, there's no sign of any unknown technology being installed. But then what could be blocking the light from this star during the darkening phases we've noticed? The most simplistic hypothesis suggests that irregular dust clouds or orbiting debris could explain this phenomenon. However, the researchers noted that the infrared wavelengths of light pass through the gradation more easily than the ultraviolet bands. For them, this observation rules out the possibility of a solid object. Could it be the debris of an exoplanet or an exolune torn apart by the star? Or could it be several groups of comets sailing alongside it, like swarms of bees? Or are they inherent fluctuations of the star itself, like the famous Betelgeuse? But in that case, why these versatile variabilities? Could it be that the star is undergoing a natural process that means it has reached a critical stage of phase transition? Whatever the case, in order to unravel this mystery, scientists need to be sure of one thing. If it's an interference due to the superposition of an occulting material, they'll have to confirm its circumstellar nature, and then its nature. If this is not the case, new alternative models for starlight could be developed. And what about you? What's your opinion on this anomaly? Just a stone's throw from this star with its strange behavior, we broach the subject of extraterrestrial entities. This must remind you of an unusual phenomenon you've probably heard of, still considered an anomaly for want of a plausible explanation. On October 19, 2017, a mysterious object was spotted as it passed through our solar system, baffling astrophysicists for many reasons, with some even considering the possibility of extraterrestrial technology coming to visit us. This fabulous object was detected by Hawaii's Pan-STARRS telescope and christened Oumuamua, scout or messenger in the Hawaiian language. Its hyperbolic trajectory and unusually high speed led to the conclusion that it came from another star system. Coming from who knows where, this bolide was the first interstellar object to visit us so closely, before continuing its long journey to an unknown destination. With its cigar-shaped ship-like appearance, it brought to mind certain cinematic images, often ominous. As you can imagine, this interastral intruder did not go unnoticed for a number of reasons. First of all, its dimensions. Measuring in length between 200 and 400 meters, or 600 and 1,300 feet, with a width 10 times less than its length. What's more, the object's brightness and variations in luminosity could lead observers to believe that it was a metallic object rotating on itself. Once again, science fiction films are full of spaceships based on similar movements. Its appearance wasn't the only thing that puzzled scientists. Its attitude proved just as disconcerting. While from a rational point of view, it resembled an asteroid or comet, it displayed neither the sparkling tail nor the halo usually attributed to the latter. Even more disconcerting was the way it crossed our solar system. When it was detected at a distance of around 30 million kilometers or 19 million miles from the Earth, its speed was estimated at 50 kilometers per second or 31 miles per second. Then, as it drew closer to our Sun, it accelerated progressively until it reached 87 kilometers per second or 54 miles per second. But perhaps the strangest thing about it was its rocket-like behavior. Indeed, after orbiting the Sun, it experienced an extraordinary acceleration as it changed its trajectory. At that very moment, it was traveling at a speed of over 300,000 kilometers per hour, or 185,000 miles per hour, heading for the constellation of Pegasus, before finally exiting our solar system. Scientists theorize that such a brief visit by such a cosmic object could have been the result of a spacecraft. Could it have been a simple asteroid, an atypical comet, a hydrogen iceberg, or the debris of an exoplanet? Naturally, researchers tried to unravel this mystery by mining the data collected, specifically those concerning this fabulous acceleration coupled with an improbable change in its trajectory. Neither a gravitational kick from the Sun nor an outgassing phenomenon seem to explain this supernatural behavior, contrary to the laws of physics. What's more, no unusual radio emissions were detected during the same period. Since 2019, a study by the Astronomy Department of the University of Maryland has settled one point. The object did not originate from an alien entity, and its natural origins were justified. According to a study published in Nature magazine in March 2023, it is a water-rich object, similar to a comet that has undergone significant weathering. It reports that Oumuamua, like comets, is essentially composed of water and rock. The object would have been propelled far from its star's gravitational grip before drifting off into interstellar space. During its long cosmic wanderings, it would have been bombarded by cosmic rays, particularly energetic particles that can penetrate dozens of meters beneath the ice. According to one model, more than a quarter of the water molecules present on Oumuamua were transformed into molecular hydrogen, which was then trapped in countless small pockets of ice. When the object got close enough to our Sun, at a distance of tens of millions of kilometers or miles, the hydrogen ice would have undergone a sudden change of state, transforming into gas. By escaping on its own, the hydrogen gas would then have propelled Oumuamua, causing the abrupt change in direction observed. This hypothesis, which holds true for many scientists, helps explain why no halo or streak was detected by telescopes in 2017. The exact nature of Oumuamua cannot be certified to this day, leading, as you've seen, to major discrepancies in the sphere of astrophysicists. This object has definitely left our solar system, taking with it a mystery that will never be solved. However, future observations by the Vera Rubin telescope in Chile, due to begin in 2025, could well change all that. Designed to detect new comets, both inside and outside the solar system, it should be able to collect relevant data on them. If, like Oumuamua, the smallest comets show signs of releasing trapped hydrogen and do not display a characteristic tail, then the existence of this new type of comet could be confirmed. How about that? Our onboard computer reports that it has recorded a radio signal that seems to be repeating itself on a regular basis. Let's take a closer look. The transmission comes from the constellation of Sobieski's Shield, east of the tail of the Serpent. The ground team confirms that they too have detected this unusual signal. They tell us they've observed the signal lasting from 30 seconds to 5 minutes, repeating itself strangely, slowly every 21 minutes. Our cross-reference data indicates that we are indeed interested in the same phenomenon. What could be behind such a radio source? Could it be an extraterrestrial radio signal? Of course it could. But let's not panic. This signal mustn't be perceived as a threat. Let me explain. This intriguing radio signal was first detected in 2022 by Australia's Murchison Wide-Field Array Radio Telescope, before being observed and then confirmed by numerous other facilities worldwide. In a study published in July 2023 in the journal Nature, researchers from Australia's Curtin University report their findings. Although they are not yet in a position to catalog the object perfectly, they do offer some explanations. It turns out that this extraterrestrial signal is emitted by an astral object named GPM J1839-10. Yes, you heard me right. It's coming from a star, not from an entity potentially in search of traces of distant life. However, this stellar object, which behaves like a pulsar or magnetar and is located 15,000 light-years from Earth, has left scientists stunned. Radio signals from such stars, sweeping across our Earth on a regular basis, are nothing out of the ordinary, you may say. And yet, there's nothing coherent about this one. As you probably know, magnetars, or dying stars, produce energy at regular intervals. These neutron stars, with their extremely powerful magnetic fields, are particularly dense, rapidly rotating objects. The flashes they produce last only a few milliseconds, rarely more than a second or two, and are repeated at a steady rate of no more than a handful of minutes. In this particular case, let me remind you that the powerful radio beams detected last up to 5 minutes and are repeated only every 21 minutes, which is inexplicably slow for such an object. Such periodicity has never been observed before. Could it be that scientists have spotted an exotic object never before discovered? Subsequent study of the telescopic archives revealed another fact about these enigmatic radio wave emissions. The scientists, totally baffled, asserted that these have been recurring since at least 1988. This means that the star has been transmitting in this way for over 35 years. In January 2022, the discovery of a similar object, J1627-5235, was also announced. This transient object also emitted strong radio emissions lasting 60 seconds and recurring every 18 minutes. However, according to recent monitoring and archive data, its radioactivity was short-lived compared with that of its counterpart. It lasted just 3 months out of 8 years of observation. If it is indeed a magnetar, such a discovery calls into question current knowledge of this class of neutron stars. As they age, their magnetic fields gradually weaken, inevitably slowing down their rotational speed. Then, when they reach the death line, the threshold at which they can no longer produce high-energy emissions, they fall silent forever. In our case, however, this limit has been well exceeded. Nevertheless, this beam of radio waves continues to rotate, like a tireless cosmic beacon. Scientists believe that it could be an extraordinarily slow magnetar, or even a white dwarf radio pulsar, but one thing is certain. Even if one of these two hypotheses proves to be correct, both involve numerous parameters and uncertainties that remain to be elucidated. Let's add this new anomaly to the many other cosmic mysteries and continue our journey. Let's make sure everything's okay, shall we? What are you staring at? What are you saying? A curious circular mist? Yes, it is. Our radio wave measuring equipment is categorical. Straight ahead of us stands a strange ring of cosmic smoke. Its ghostly appearance partially obscures the stars in the background. If we were observing it through a telescope, I'd certainly advise you to clean your lens. A priori, this enormous structure, large enough to contain entire galaxies, is only detected in the radio range. None of our other measuring devices seem to perceive it. This reminds me of a recent discovery. I think we're looking at an odd radio circle, or ORC for the more erudite. The first such object was detected in 2019 by astronomer Anna Kapinska. When she presented this image to Ray Norris, a science professor at the University of Sydney in Australia, she named it WTF, for what the fuck, which shows just how disarming, even frightening, this discovery proved to be for her. Before publishing the result of this astounding discovery, the astronomers preferred to wait several months. In particular, they wanted to be sure that the signal detected was not an astronomical mirage that could be attributed to the measuring equipment. Further data collected by an Indian radio telescope confirmed this unusual discovery. No plausible explanation for this strange radio circle, which resembled a ball of smoke, could be found. For some, this puzzling phenomenon could be linked to a wormhole. For others, it could be the result of an explosion in a deep space galaxy, or a collision between a powerful neutron star and a black hole. Just a few days after this exceptional discovery, a second strange radio circle was detected, proving that this was not a unique case. To date, only 11 strange radio circles have been spotted, but researchers believe that thousands more could well be discovered in the not-too-distant future. However, observing them is proving very difficult. These structures, although colossal, with a diameter of several 100,000 light-years, 10 times wider than our own Milky Way, are billions of light-years away. What's more, as mentioned earlier, they emit light only at radio wavelengths. Since then, Ray Norris and his team have taken a very close look at the very first strange radio circle discovered. To do so, they used the Meerkat antenna array at the South African Radio Astronomy Observatory. With 64 domes, each measuring 13.5 meters, or 45 feet in diameter, this is the world's most sensitive and precise radio wave equipment. The anatomy of this foggy ball has been revealed to scientists, revealing itself to be far more complex than presumed. The spherical structure is made up of several intersecting arcs. Above all, at the very heart of this system, a tiny dot has been spotted. It is possible that this dot, which also appears in images taken at other wavelengths, is an immense elliptical galaxy. For the researchers, there's almost no doubt. These two elements, the strange radio circle and the galaxy, are linked, the latter probably being at the origin of this anomaly. But how? The origin of this huge ring of radio waves remains a mystery, and various hypotheses are being discussed. The first suggests that the galaxy in question experienced a period of intense star formation. Their successive cataclysmic births and deaths would have violently pushed back the surrounding gas and particles, triggering an expanding shock wave. The second theory suggests a collision between two supermassive black holes located in the interior of this galaxy. This strange radio circle would then be a shell formed by outgoing galactic winds. This scenario, if it exists, has never yet been observed, although it is one that greatly arouses the curiosity of astrophysicists. Finally, others believe that we are simply looking at the barrel of a powerful jet, emerging from the active nucleus of this same galaxy. As the exact origin of these strange radio circles remains unresolved, I suggest we divert our trajectory so as not to travel too close to this gigantic structure. After all, the consequences it could have on our interstellar journey are unknown. Now that we've reached cruising speed, I suggest you take in the scenery. Look out into the distance. The stars are covering the cosmos in all their glory. You have the privilege of admiring an area of space that is home to a huge cluster of galaxies. Meet the Giant Arch. With its crescent shape, this grouping extends over 3.3 billion light-years. Distant from our galaxy by 9.2 billion light-years, it is one of the largest structures ever observed. Made up of galactic clusters, galaxies, and abundant amounts of gas and dust, it stretches across nearly 1/15 of the observable universe. To give you an idea of its scale, the giant arc, if visible to the naked eye from Earth, would represent, despite its remoteness, almost 20 times the width of the full moon. If it was only discovered in 2021, it's because such a structure, according to established models of the cosmos, isn't supposed to exist. According to the Standard Model, the current theoretical limit predicts that the size of a structure should not exceed 1.2 billion light-years. And yet, the 45 to 50 galaxies in the giant arc are bound together by gravitational forces, as in any galaxy group. It was therefore detected by chance, while a scientist named Lopez was assembling maps of objects in the night sky using the light from 120,000 quasars. She then realized that the specific signature of certain halos from several dozen galaxies was similar. Mapped in 3 dimensions, the structure discovered turned out to have this atypical arc shape. To assess the probability of galaxies forming such a vast alignment in space, the scientists used 3 different statistical methods. All of them showed that the hypothesis put forward was not all that fanciful. The discovery of this gigantic galactic arc calls many things into question, but it's not the only one to baffle astrophysicists. The Great Sloan Wall and the giant GRB ring, with respective diameters estimated at 1.38 and 5.6 billion light-years, are 2 other unlikely groupings already observed. The Great Wall of Hercules Corona Borealis, visited a little earlier, remains the largest known structure in the universe, totaling 10 billion light-years, whose existence also continues to raise many questions. With our eyes immersed in this ultra-large structure, we've completely forgotten about our surroundings. Let's take a step back and look at the giant arc's surroundings. What do you notice? Isn't there another imposing structure looming in front of you? In this same region of the universe, close to the constellation Bouvier, another grouping of galaxies forms a gigantic ring of light. But unlike other circular structures, this one resembles a helix, taking the form of a complex spiral. While this unusual appearance is striking for any seasoned observer, its dimensions are once again beyond comprehension. This colossal structure, with a diameter of around 1.3 billion light-years, has only just been detected. The announcement of its fortuitous discovery was revealed, also by Alexia Lopez, at the 243 meeting of the American Astronomical Society, which has just taken place at the start of 2024. The Great Ring, as this new structure has been christened, is almost similar in size to the giant arch discovered 2 years earlier. If this structure could be opened up into a curved shape, its circumference would equal the length of the giant arch. To get a better idea of the ring's gigantic size, consider that if it were visible to the naked eye from Earth, it would cover the night sky like 15 full moons in a row. In addition to their extraordinary dimensions, i.e. in excess of 1.2 billion light-years, the theoretical size limit, these 2 giant structures also raise another question for cosmologists. Given that the giant arch and the Great Ring are located in the same region of the cosmos and at the same distance from Earth, is it possible that they are connected to each other? In short, that they are part of the same, even more extraordinary cosmological system? These latest discoveries add up to new evidence that compromises our current understanding of the universe. Once again, the cosmological principle that matter is homogeneously distributed throughout the universe may well be proven wrong. Shouldn't scientists start examining this possibility? Shouldn't they shatter what they once believed to be irrefutable, i.e. all manner of theories and rules governing the laws of the universe? Crazy as it may sound, many scientists say they're ready to consider it. But before they can do so, they'll need even more convincing arguments. For this, new research in the direction of as-yet unexplored objects or structures, which are consequently very difficult to detect, will have to provide new tangible proof. However, another argument is also being debated by astrophysicists. Some so-called impossible or early galaxies tend to confirm that the cosmological principle may well be obsolete. Thanks to new observations by the James Webb Space Telescope, scientists have discovered almost half a dozen galaxies that appeared just after the Big Bang, displaying unexpected characteristics. To everyone's surprise, these galaxies are so massive that they could call into question their very origin. Joel Leha, professor of astronomy at Penn State, announced that instead of tiny galaxies, they had detected disconcertingly massive ones. These turned out to be as mature as the Milky Way in a region of space then considered the dawn of the universe. The galaxies studied show a redshift, appearing to be approximately 13 billion light-years old. Admittedly, according to scientific consensus, our universe was born some 13.8 billion light-years ago. But that means they would have reached maturity in just a few 100 million years after the Big Bang. The idea is simply inconceivable according to the standard cosmological model. These luminous groupings of stars are so massive that they are impossible in 99% of models of the early universe. What's more, they are astonishingly small, adding to the mystery surrounding them. So how do we explain their existence? How can galaxies from the early universe be in such an advanced state of growth, corresponding to billions of years of cosmic evolution? For the researchers, there had to be a mistake. Although every effort was made to locate it, it could not be found. Could it be that galaxies were formed more than 26 billion years ago? That's what Earendel Gupta, assistant professor of physics in the Faculty of Science at the University of Ottawa, suggests. For this scientist, our universe could actually be twice as old as current estimates. This would not only shed new light on those impossible early galaxies, but also provide an explanation to the existence of stars like Methuselah, the stellar Doan that seems to have been shining longer than our universe. Earendel Gupta is the originator of a new way of thinking and explains how his model stretches galaxy formation times by billions of years. In this hybrid model, he combines the evolution of Paul Dirac's coupling constants with a controversial theory, Zwicky's tired light theory. According to this theory, the redshift of distant galaxies is due not to the expansion of the universe, but to a gradual loss of photon energy. The photons would be progressively stripped of energy as they traveled the very long cosmic distance to the observer. As for Paul Dirac's coupling constants, these are fundamental physical constants that govern the interactions between particles. These may have changed over time. To sum up, according to the synthesis proposed by Professor Earendel Gupta, the redshift exhibited by these incredible galaxies could be attributed to two phenomena. One is the expansion of the universe, the other is the fatigue of observed light. For the scientist, our universe could therefore be exactly 26.7 billion years old. The distant universe fascinates astrophysics experts and enthusiasts alike, all the more so when our Earth is hit by one of the most energetic cosmic rays ever recorded. Named Amaterasu, this strange cosmic ray was detected on May 27, 2021 by the Array Telescope Network. With its unrivaled power, it surpassed the first phenomenon of its kind detected in 1991, named Oh My God, and which motivated the Telescope Array project. Over the past 3 decades, more than 30 ultra-high energy cosmic rays have been detected, but none of them reached the power displayed by Oh My God until this latest discovery. Nicknamed Amaterasu after the Japanese goddess of the sun, this cosmic ray, composed of accelerated particles, is baffling scientists for several reasons. The first, of course, is its extraordinary power. The kinetic energy of just one of these particles has been estimated at that of a tennis ball thrown at nearly 150 kilometers per hour, or 90 miles per hour. While this ray, invisible to the naked eye, has remained in the shadows for the average person, it did not fail to panic scientists' measuring instruments when it was detected in the Utah desert. But even more disconcerting is the fact that nothing seems to be at the origin of such a phenomenon. Neither our galaxy nor neighboring galaxies. Indeed, after tracing its trajectory, the researchers were able to trace the source of this cosmic ray, or so they hoped. After all, it seems to come from a region of our universe that is virtually devoid of galaxies, and therefore relatively poor in matter. So how do we explain this flow of atomic nuclei and high-energy particles? What mechanism could have generated this extraordinary cosmic ray? Once again, to explain Amaterasu's origin, everyone has their own hypothesis. For some, it could have been particles emitted from our galactic surroundings, an event sufficiently discrete that no energy release or gamma-ray burst is detected by our instruments would then be the origin. This hypothesis calls into question the distant origin of the cosmic ray. A second theory suggests that the cosmic ray was deflected by an extragalactic magnetic field much more intense than originally thought. But the energy of the particles is so high that they should not have been affected by any magnetic field. Finally, the last hypothesis raises the possibility that this particle could confirm physics unknown to the standard model of particle physics. Critics also suggest that the Array telescope may have overestimated the energy of the cosmic ray. What's more, the exact nature of the particle detected is still an unknown factor that can change everything. Is it a proton? Or, for example, an iron atom? As in so many other cases, this discovery only adds more mystery to our universe, which is proving to be ever more complex. One of the most recent discoveries once again challenges our understanding of the cosmos. A team of astronomers from the U.S. Green Bank Observatory, led by Karen O'Neill, has just made an unprecedented announcement. A unique galaxy, christened J0613+52, has just been spotted. What's special about it? It has no visible stars. So the image we have of a galaxy as an immense grouping of luminous stars bathed in gas and dust is not always accurate. So say the astronomers who have just inadvertently pointed their telescope in its direction. The discovery, which was totally fortuitous, was due to an input error. As Karen O'Neill explains, an operator inadvertently set the Green Bank telescope to the wrong coordinates. Without this oversight, the object 270 million light-years from Earth would have remained in the shadows, and with good reason. It's a low-surface brightness galaxy, which is extremely faint, even for this type of galaxy. Aware of this parameterization error, the astronomers nevertheless decided to take a closer look at this structure, which at first glance seemed insignificant. Their curiosity paid off, enabling them to make a completely unexpected discovery. They soon discovered that unlike other galaxies with low surface luminosity, this one is particularly rich in gas. Its chemical signature suggests that it contains abundant quantities of primordial gas. Like spiral galaxies such as the Milky Way, it contains mainly hydrogen and helium. After measuring the wavelength shifts, an undeniable fact emerged. This galaxy seemed to rotate in the same way as an ordinary spiral galaxy. This gas cluster has all the characteristics of our own Milky Way. Its mass, composition, and motion all match, except for one thing. There are no stars in this vast gaseous region. Scientists have a new enigma to solve. Have they discovered one of the first primordial galaxies, which underwent no transformations during its 13.8 billion years of existence? Why didn't this galaxy, so massive and holding these elements formed shortly after the Big Bang, enrich itself, like its counterparts, through stellar explosions in the course of its evolution? For Karen O'Neill, the gas in this structure is too diffuse to allow it to collapse in on itself under the influence of gravity. What's more, this galaxy is totally isolated from any other structure in its immediate vicinity. It seems never to have been disturbed by any other galaxy. But these explanations are not enough to demystify this unique and fascinating recent find. Indeed, it's unlikely that over such a long evolutionary period, no gravitational force has ever disturbed its peaceful existence. And yet, this is what it seems to demonstrate. To better understand the nature and dynamics of the early universe, scientists will have to be patient. Future discoveries of cosmic bubbles that have not undergone any reshaping should help elucidate this anomaly, but they still need to be detected, as they are particularly discrete. Now it's time to return to our magnificent planet Earth. Let's plan our return. However, there's one last anomaly we'll need to overcome if we're to return in the best possible conditions. Our trajectory must absolutely avoid a vast zone located between South America and the southwest of the African continent. You may not know it, but this area is known as the South Atlantic Anomaly. It turns out that in this region covering the globe, a curious phenomenon has been intriguing scientists for several decades. The intensity of the Earth's magnetic field is unstable and much lower than in the rest of our planet. If we were to cross this zone, the consequences could be terrible for our spacecraft. Bombarded by high-energy particles emanating from our sun, all onboard technology could suffer interference, or even worse, a disastrous malfunction. But rest assured, this phenomenon, although unexplained, is not new, and we know perfectly well how to dodge it to bring this fantastic voyage to a close.